Okay, so as per their request, we will revise the DC generator from first concept of a DC generator. Okay, so basically, the firstly we will see the syllabus structure of a DC generator. In that, electrical machines having a weightage of 30 marks for internal examination, that is ISE, then 70 marks for the external semester examination, that is 70 marks, and the total marks are 100. Okay, so like that way, syllabus we will see the DC generator which having construction basic principles as well as EMF equation, their types of windings as well as characteristics, and their applications of different types of DC generators. How these armature reaction is what is the concept of armature reactions as well as commutation, that cross magnetizing MMF, then how we will recover or improve that armature reaction as well as commutation, all that things we were going to see in a DC generator. Again, in DC motor, same principles, working principles, constructions, back EMF concepts, torque equation, their types of motors, losses, efficiency, power flow, as well as there are various kinds of the starting controls that starters we are going to see in a DC motor. Similarly, testing of that all DC motors we will see in third unit, that is a direct or indirect methods, and Swinburne as well as Hopkinson test, which is only practical part. Okay, and in second section there is a single phase transformer and three phase transformer. So there is transformer construction types, bulking principles, the EMF equation, voltage regulation, what is the transformation ratio, transformers equivalent circuits, losses, efficiency, what is the condition for the maximum efficiency, all that basic things, parallel operation, open circuit test, short circuit test. Okay, what is a auto transformer, so all that center type transformer, all that things we will see in a single phase transformer. Then three phase transformer, there is a star delta transformer. Okay, then delta delta connection, all the special constructional features of a three phase transformers, as well as how these three phase to two phase conversion is there, all that things we will see. Swagat Bhandare, mute yourself. Rushkesh, just count how many direct second year students are there. Okay.
Okay, sir.
Yeah, fine. So from before starting the DC generator, we will move toward the basic laws. Whatever there is a Faraday's law of electromagnetic induction and Lenz's law is there. So if we understand these two laws, then there is a easiest way to understand the working principle of DC generator. So Faraday's law of electromagnetic induction, I request from direct second year students, is there anybody who can explain? Prajakta, Amruta, Rita, Vaishnavi, Amay Kumar, please explain me what is the you can you just learn Faraday's electromagnetic law of induction. So you please tell me. Anybody but from you guys? Huh. Okay. Raviraj, roll number 20.
Yes, sir.
Actually, I think this is your first lecture, na?
No, sir.
Then I don't see you in various lectures currently, because every lectures you were absent. I am just watching, as I am a CC, I know every lecture's attendance for every subject. So there is absenteeism of you. What's the problem?
Sir, is family problem.
Okay, so कधीपासून लेक्चर करताय तुम्ही? रिसेंटली
केलते करतोय की.
ओके, तुमचा करंट मोबाईल नंबर काय आहे चालू?
75
एक मिनिट, माझ्याकडे जो आहे तो तुम्हाला मी सांगतो, तो चालू आहे का तो सांगा. कारण तुम्हाला मी भरपूर ट्राय केलेला आहे कॉल करायला. 75 58 52 41 60.
हो सर, हाच आहे की.
90 49 50 81 14
तोच आहे सर.
हे दोन्ही नंबर तुमचेच आहेत.
हा.
मग कॉल का लागत नाही तुम्हाला? लागला तर मग तुम्ही उचललेले नाहीत कॉल.
नाही सर, आलाच नाही.
नाही, मी केला कॉल तुम्हाला, भरपूर वेळा कॉल केला. तुमचा कधी कधी नंबर इनव्हॅलिड सांगतोय.
नाही सर.
एक जस्ट मिनिट, मी तुम्हाला कॉल करतो.
हा. हॅलो.
हा, तुमचाच नंबर आहे ना हा?
हा हा सर.
ओके, ठीक आहे. इथून पुढे लेक्चर्स करा. तुमची अटेंडन्स खूप कमी आहे, सो इथून पुढे मी रिक्वेस्ट करतोय तुम्हाला की लेक्चर्स इथून पुढे सगळे कंटिन्यू करा. ठीक आहे. टेस्ट वगैरे दिला का तुम्ही?
ओके. हो सर.
सगळ्या दिल्या का?
हा.
ओके, गुड. ठीक आहे. सो आता
हा.
तुम्ही हा, मला वाटतं डिसिजन जनरेटरच्या पार्टला नव्हते, सो आपण रिव्हिजन घेत आहे. त्याच्याबरोबर डायरेक्ट सेकंडचे स्टुडंट तुम्ही पण लक्ष द्या. सो तुमचं रिव्हिजन पार्ट मध्ये सगळं क्लिअर होऊन जाईल. एक आज आणि उद्या 1-2 दिवस लेक्चर आपण रिव्हिजन वरती देणार आहोत. ठीक आहे. ओके, तर
ओके सर.
हा, डायरेक्ट सेकंड इयर स्टुडंट्स, तुम्ही सांगताय की मी तुमच्यापैकी एकाला कोणाला तरी विचारू? ओके, विल स्टार्ट फ्रॉम फर्स्ट. अमेय कुमार.
मी सांगते सर.
हा, येस वैष्णवी, व्हेरी गुड. टेल मी.
Whenever can magnetic field, it cuts the magnetic field and express the force.
Okay. Anybody else? Vishnu, very good. हाँ, anybody else? Prajakta, Priyanka, Amay Kumar, Amruta. Sripad, Swagat. Yes, please. If there anybody want to explain electromagnetic law of induction, please tell me. No. सेकंड इयरला झाले की नाही डायरेक्ट सेकंड इयर? ओके, फाईन. मीच सांगतो. तर पहा, जेव्हा आपला कंडक्टर जो आहे तो जेव्हा एका मॅग्नेटिक फील्ड मध्ये आपण घेऊन जातो, ऍट दॅट टाइम तो कंडक्टर त्या मॅग्नेटिक फील्डला काय करतो, जिथं त्या मॅग्नेटिक फील्ड मध्ये ज्या लाईन ऑफ फोर्स असतात, म्हणजे जे फ्लक्सेस असतात, त्यांना तो कट करतो. आणि त्यांना जेव्हा तो कट करतो, तर त्यावेळेस त्या कंडक्टर मध्ये एक इलेक्ट्रोमॅग्नेटिक फोर्स तयार होतो, म्हणजेच ईएमएफ तयार होतं. ओके. आणि ही जी काही ईएमएफ तयार होतं ते कशावरती डिपेंड असतं, तर जो काही तुमच्या मॅग्नेटिक लाईन ऑफ फोर्स, म्हणजे जी तिथली मॅग्नेटिक फील्डची स्ट्रेंथ असते किंवा तिथले जे मॅग्नेटिक फ्लक्सेस असतात, त्या फ्लक्सेसचं जे कंडक्टर सोबत जे लिंकेज होईल त्याच्याबरोबर ते काय असतं, डिपेंड असतं. सेकंड थिंग, ईएमएफ जे जनरेट होतं ते जनरेट झालेल्या ईएमएफ मुळे काय होतं, तर तिथून करंट फ्लो व्हायला भाग पडतं सर्किट मधून. ओके. सो हा सिंपल मराठीतला कन्सेप्ट आय विल एक्सप्लेन इन इंग्लिश सो यू विल अंडरस्टँड इझिली. Whenever current when current moves whenever conductor moved inside the magnetic field, at that time it cuts the magnetic line of forces, that is a magnetic flux. Due to that there is induction of EMF. Okay, so that induced EMF or the magnitude of that induced EMF is depending upon the rate of change of magnetic flux linkages with the conductor. Also, that due to EMF there is a reason to flow the current into the circuitry. Okay, when that circuit is in closed condition. Okay, so basically as I told you, there are two essential parts in the system. First is a conductor, second is a magnetic field. Okay, now how this Lenz law comes under this generator. So see, first thing, as I told you, that due to EMF there is cause a current to flow if the circuit is closed. So whenever that current is flowing, at that time the direction of that current due to that induced EMF. Okay, as per Faraday's electromagnetic law of induction, the direction of the current induced in a conductor circuit, okay, is like that the magnetic field created by the induced current. See, whatever I am trying to say you, जे काही तुमचा करंट जनरेट होतोय तो काय करतोय, त्या मॅग्नेटिक फील्ड मुळे जो काही करंट जनरेट होतोय तर तो काय करतोय, तर तिथली जी इनिशियल ना जी मॅग्नेटिक फील्ड असते ती तिला तो काय करतोय, अपोज करतोय. इथे लक्षात, थोडक्यात लेंज लॉ म्हणजे काय, तर जो काही ईएमएफ तिथं जनरेट होतोय ड्यू टू द इलेक्ट्रोमॅग्नेटिक इंडक्शन, जे काही ईएमएफ जनरेट होतोय आणि त्याच्यामुळे जो करंट फ्लो होतोय तर तो तयार होणारा करंट हा त्याच ईएमएफ ला अपोज करतो. दॅट्स द सिंपल एज ऑफ इट. ओके, so based on these basic laws our DC generator will work. So now we'll see whatever the constructional part of a DC generator. So basically there are three subsystems in a generator, that is a magnetic field system, that is armature and commutator and the brush gear. So firstly we will see magnetic field system. Again, that magnetic field system consists of that stationary part, that is a fixed part, which is nothing but magnetic field system. So in that field system, what is the aim of or working of that field system? To provide the magnetic fluxes or main magnetic fluxes which will provide by the magnetic field system. Again, in that system there is a main frame or yoke, again pole core, pole shoes, field windings, all that parts comes under the magnetic field system. So we will go one by one, that is the magnetic frame and yoke. So that is used to support the pole shoes and for the provide mechanical protection to the internal parts of the machine, as well as it provides low reluctance path for the magnetic flux. Now as I have already explained during continuous lectures, that there are two kinds of circuits. So I will draw here for the direct secondary students understanding. Okay, so I will just make partition here. I will write here E and I will write here M. So this E stands for the electric circuit and this M stands for the magnetic circuit. So E, like electric circuit, if there is a EMF, what is in magnetic circuit? मॅग्नेटिक सर्किट मध्ये काय असतं, MMF. Then like here there is a current, I will write current I. Similarly in magnetic circuit, fluxes, right? Then again here this EMF is known as a V, this MMF is known as a AT. Okay, AT means what, that ampere turns is nothing but MMF. Okay, am I right? झालेलं आहे आपल्याला, मी सांगितलेलं आहे ऑलरेडी. Then in electric circuit there is a resistance, that is the R. In the MMF circuit there is again R, which stands for reluctance. Okay, so now you just clear that, as we need to, जर आपल्याला करंट फ्लो व्हायचं असेल तर आपल्याला काय लागेल, रेजिस्टन्स कसा लागेल, कमी लागेल, बरोबर? Because we know that as per Ohm's law V is equal to IR. So if this R is greater, then our current will flow little bit. So to flow the maximum current we require resistance value is low. Similarly, to flow the maximum fluxes, reluctance should be low. Am I right?
Yes, sir.
Right now. So same thing as I told you, like that if this is our main system and जर आपल्याला, मी तुम्हाला ऑलरेडी सांगितलं की आपलं जे EMF जनरेट होणार आहे ते कशावरती डिपेंड आहे, तर दोन गोष्टीवरती, एक कंडक्टर आणि एक मॅग्नेटिक फील्ड वरती. तर आपली मॅग्नेटिक फील्ड कशी असली पाहिजे, जर जास्त असेल, तर ईएमएफ काय होईल, जास्त जनरेट होईल की कमी जनरेट होईल, जास्त जनरेट होईल. तर मग आपलं जे तर आपली जी मॅग्नेटिक किंवा मॅग्नेटिक फ्लक्सेस आहेत, मॅग्नेटिक फील्ड म्हणजे काय, मॅग्नेटिक फील्ड म्हणजे काय असतं पहा, ही अशी एक फील्ड असते, याला म्हणायचं मॅग्नेटिक फील्ड. आता ह्या फील्ड मध्ये काय असतं, तर या फील्ड मध्ये अशा मॅग्नेटिक लाईन ऑफ फोर्सेस असतात, बरोबर, मॅग्नेटिक लाईन ऑफ फोर्सेस असतात, त्यालाच आपण म्हणतो फ्लक्सेस, बरोबर. तर आता मला सांगा, जर मॅग्नेटिक फील्ड जास्त आहे म्हणजे फ्लक्सेस काय पाहिजेत, जास्त पाहिजेत की कमी,
जास्त.
फ्लक्सेस जास्त पाहिजेत म्हणजे रिलक्टन्स कसा पाहिजे, कमी पाहिजे, एक्झॅक्टली. सो दॅट मॅग्नेटिक फ्रेम किंवा ती योक जी असते, तर ती काय काम करते, तर लो रिलक्टन्स पाथ प्रोव्हाइड करते फॉर द मॅग्नेटिक फ्लक्स, जेणेकरून आपले फ्लक्सेस हे जास्त करून फ्लो झाले पाहिजेत. सो दॅट इज दॅट मच सिम्पल. ओके, I think I have cleared your doubt. Okay, next one is a construction. See here, there is a stand that also outer part is nothing but our, why is changing automatically? Yeah, see here, this outer part is a frame. Okay, frame or yoke I can say. So as I told you, this part is for the mechanical support as well as to provide the low reluctance path. Again, this N and S is nothing but our poles, and also the winding which is mounted on this pole is nothing but field winding, and the winding which is mounted on the, see this is a, this holes you can see, this 0 0 0 0, this is nothing but armature winding which is armature conductor, that is a rotor. Okay, and the winding which is placed on that is nothing but armature winding. So in generator, field winding is placed on a poles. Okay, so you can say field winding is a stationary part and armature winding is a rotationary part in a generator system. Again, there is a interpoles which are placed in between two similar poles. We will discuss about interpole further. Then pole shoes are there. Pole shoes. This is the pole cores. Commutator segment is also here. Okay. And this is our shaft. Okay, where we will add the or couple the motors or load. Okay. So pole cores and pole shoes are fixed to the magnetic frame, as I have shown you that pole core. See here, this pole show, wait a second, this is a pole show, and these pole shows are fitted with this magnetic frame or yoke. See, you can, this is also pole show, this is also pole show. So all pole show and pole core as already connected or already fixed at a course, like directly magnetic frame. Okay, and also it is fitted by the nut and bolt. So each pole core has that like a curve. So here separately individually मी इथे एक डायग्राम घेतलेली आहे, ज्याच्यावरती तुम्हाला दिसून येईल की लॅमिनेटेड पोल कोर्स आहेत, त्याच्याबरोबर इथं जे तुम्हाला पोल फिक्सिंग साठी दिलेले आहे, थोडक्यात होल्स आहेत फिक्सिंग साठी, हे खिळे असतात त्याच्यामध्ये. देन देर इज अ सेक्शन ऑफ field winding where we can mount. Also there is a laminated pole shoes. Okay, so these pole shoes are laminated. Why? Because to reduce the eddy current losses. So again we will see that about eddy current losses, why it is laminated in losses section. We will see that one also. So as pole shoes function is that to support the field winding, whatever the field winding is mounting on poles, so the pole shoe will support that to field coil or exciting coils. Again, uniformly this pole show will spread out the magnetic fluxes into that magnetic field system. Okay, as well as it will increase the cross sectional area. So as a result, if cross sectional area will increase, due to that reluctance will automatically get reduced. Okay, so this is about the pole core and pole shows. Again, magnetic field coils or fixed coil, exciting coils. That field coils means what? The coils which were placed to produce the magnetic field. Okay, so this field coil is made up of a copper coil or copper wire, and these coils are wounded on a pole core or around the pole core. So when current passes through that winding, at that time this winding will magnetize the poles, and due to that magnetization of poles there is a production of fluxes. So these field coils of all poles are connected in a series with each other, so that the current will flow through them, and all the poles or all adjacent pole will attain the exactly opposite polarity to each other. Similarly, armature core is there. Armature core is nothing but a cylindrical in a shape, that is a rotor which is in a cylindrical, and the outer periphery of that armature is a groove. So like that, see, this is a grooves. So that grooves means what? There is a slots to place the armature winding. You can see, or if anytime you have seen the practical example of that same, then you can understand. Okay, so that is that grooving for to house the armature conductors in a separate slots. Also, also it will provide the easiest path for the magnetic fluxes to the flow out. So again there is a commutator. Again we will see commutator in a separate manner, but here commutator which rotates with the armature. See, here is a commutator segment, that is a commutator segment which is connected over the shaft. So it is also in cylindrical in a shape, and also made number of way shape with hard copper bar. Okay, so the most important part of the DC motor is nothing but commutator, because this commutator connects rotating conductors to the stationary external circuit through the brushes. So that means whenever brushes will collect the current, and then this current will gives to the commutator, then it will convert it this current into alternating current. Okay, so this is connected in the external load circuit, as well as it converts the alternating torque into a directional torque produced in a motor armature action. So like brushes which are made up of a carbon, as I have put that question in MCQ test for 2 times, that brushes are made up of carbon, but still you people are missing that. Also each and every brush is supported by the metal boxes, where brush box or brush holder we can say, and these brushes are pressed upon the commutator segment. Okay. Then again end housing म्हणजेच काय, end plates. This is used to provide the support for the bearings. Okay, so these end housing are there. Bearings कशासाठी असतात, तर bearings या फ्रिक्शन कमी करण्यासाठी असतात. रोटेशनरी पार्ट आणि स्टेशनरी पार्ट्स मध्ये जे काही एक्झॅक्टली रोटेशन्स असतात, तर टू reduce that friction, that bearings are used. Again, shaft is made up of mild steel which having a maximum tensile strength as well as breaking strength, and the shaft is used to shift the or transfer the mechanical power into or from the motor. Okay, so we will come to the DC generator working principle. So in the DC generator, first of all you should understand what is the Fleming's right hand rule. So I will explain the Fleming's right hand rule firstly, and then we will go for next. So see, whenever as I told you, electromagnetic induction law, that law explains whenever current whenever conductor is placed or moved in a magnetic field, it cuts the EMF and it will induce EMF. So similar principle is there for the generator, as there is a rotating conductor. Okay, for a generator little bit working principle is different, for motor it is a little bit different. So for generator I will explain, you just understand. Whenever rotating conductor placed in magnetic field, okay, whenever I am explaining again, whenever rotating conductor, that is armature, whenever rotating conductor placed in a magnetic field, it cuts the magnetic fluxes, it cuts the magnetic fluxes, and EMF will get induced in that conductor. Okay, whenever rotating conductor placed in a magnetic field, then it cuts the magnetic fluxes, and due to that EMF will get induced in the conductor. Okay, so the magnitude of that voltage or the EMF generated is directly proportional to the rate at which the flux linkages or the flux lines are cut by the conductor. येते लक्षात. आणि second thing, direction of that induced EMF can be predetermined by using Fleming's right hand rule, which explains whenever right hand's first three fingers we kept perpendicular to each other, then thumb will indicate the direction of motion. Second thing, index finger will shows the direction of magnetic field, whereas the middle finger will direct us the direction of induced EMF. So I hope you will understand. So we'll go for next diagram. See here, at zero position we will consider here, this is a, see, this is a south pole, north pole, and in that the rectangular coil is placed, where this is nothing but what, there are two brushes which are connected to the two end of this rectangular coil. Here A, B, B dash, A dash is a rectangular coil. So now in between these two magnets there is a magnetic line of force, and already you know that magnetic field that fluxes will flows from the north to south always. Okay, so now we are rotating that coil at a zero position. At that moment there is no cutting of a magnetic line of forces, due to that there is a zero induced voltage. But at whenever we will rotate that one, then we'll go for this next one. So in that, whenever we will change the position of rectangular coil and it will move to 90-degree position, at that time you can see this orange mark is going to incline, and due to that there is a cutting of magnetic. Hello, am I audible clearly? Hello.
Yes,
No,
sir.
sir.
Yeah, who is facing issue? Please let me know.
सर कट होता
Hmm?
आवाज सारखा.
Okay, is it okay now? Hello. Is it okay?
Yes sir.
Yeah, fine.
Yes sir. Yes.
Yeah, fine. So similarly, at a 90-degree position, then the coil A will become a positive with respect to B, and the current direction is out of the slip rings, you can see. So while current is flowing through the closed circuit, then this lamp will glow. Okay, so at that moment we will get, as all the magnetic lines of forces will be cut by the rectangular coil, so there is a maximum generation of EMF, and in waveform you can see at 90-degree there is a maximum EMF generation. Similarly, again we will continue to rotate that coil, and once we will rotate and comes to the 180-degree, at that time again same situation, whatever in A diagram, that is 0-degree position, but the direction will be reversed. See here, A dash is on upward position, here in a downward position. So again at 180-degree position, magnetic line of force and our rectangular coil both are in parallel with each other, so due to that induced voltage will become again zero. So that means at 180-degree it will comes to the zero. Then again while we will continue to rotate, then it will move to the 270-degree position. At that time polarity has reversed, but similar voltage whatever generated in 90-degree position will generate here, and you can see the reverse current will flow. See here, the direction of current is like that way. Okay, and in this diagram you can see current direction will just reversed. Okay, so here you can also see at 270-degree the voltage is generated whatever at 90-degree, but 90-degree generated voltage is in a positive, and in 270 there is a negative. Similarly, if we continue to rotate, then again it will move to the 360-degree, that is 0-degree, and again it will becomes to zero. So this is the simple alternating waveform we will get from the generator, that is a single loop generator's working principle. I hope you understand, and we have already learned that, so we'll just only revising that terms. Okay, Fine. So what we will do, we will see that AMF equation of DC generator in next lecture. Okay. So as currently right now I am facing some internet issue as well as okay, a little bit health issue. So we will stop here. After 15 minutes, you please join another lecture. Okay. Next lecture at 11 p.m. Okay. So is there any doubt in a construction, in a basic law, in a working principle?
Hello, sir.
Yes.
Hello.
Yes, Vaishnavi, tell me.
I have
I'm
a
listening.
question, sir.
Yeah, please.
Why the brush is made from carbon, not for copper, aluminium?
See, one thing is there. What is the use of that brushes? That brushes are only to there to collect the current. Okay. So as we know that the,
From commodity.
sorry, my voice is not proper. Hello.
Oh, sir.
Okay, no problem. I will send you explanation or we will cover this question in next lecture because I just having an internet issue. Okay. Hello. Am I audible? Vaishnavi, we will cover this answer in next lecture. As right now I am facing little bit internet issue. Am I clear?
Yes, sir.
Yes, sir.
Yeah,
Yes, sir. Yes, sir.
yeah. Okay, so we'll stop here and we'll continue in next lecture. Please join 11 a.m. lecture now.
Okay, sir.